Good morning to all. Myself Jogad. Welcome to Sri Guru online classes. Today I am going to discuss first year second part first lesson, that is mechanical properties of solids. I am going to discuss mechanical properties of solids. Mechanical properties of solids. Why we are discussing solids only? Why not liquids and gases? We are going to discuss liquids as well as gases in the further classes. In this class we are discussing about the elastic nature of solids. Elastic nature. Why we are considering only solid materials means we know that already it has definite shape as well as volume, definite shape and volume. That's why we are discussing this solid. Why not liquid means liquid does not have any definite shape as well as the volume, it depends on the containers. Gases is also similar property. That's why we are considering solid bodies elastic properties. Okay, let us discuss the elastic nature. And if suppose that body is not elastic means what we are going to call that as plastic. We'll discuss those things first. What is elastic? What is elastic? Elastic means the material which regains its original shape after removal of that external force is acting on that particular material. For example, let us consider this is our original position. If suppose we applied a certain force on it, definitely this body will come back to its original position. We can say that this is also elastic property. At a certain limit it is going to regain its original shape after removal of this external force. We are applying external force. Because of this external force, the body is going to change its shape. After removal of this force, the body will come back to its original position. But it is going to take time to regain its original shape. But elastic materials such as steel elastic materials which regains fastly as compared to this. That's why steel is more elastic than all other materials. Okay, what is the general definition for elastic? The property of a body by virtue of which it regains its original shape or size after removal of external force is called as elasticity. Here we are applying a deforming force. This deforming force causes a body gets deformed. Body is changed its shape. After applying a force, its body shape is going to change. Deformed. After removal of this deforming force, the body come back to its original configuration. Original configuration or original shape or size. Listen here, this body will come back to its original position. How it is going to come back? Which property will help to regain this body? That property or that type of force we call as restoring force. Restoring force. Let us consider here. This is initial length of spring. Let us consider L. After applying a force, its length is going to increase. Here we applied a certain force. Certain force means definitely this is a stretched force that we call as a deforming force. Because of this deforming force, the length is going to increase, that you just considering as L dash, change in length. This much of length is increased. When we apply the deforming force, the body acquires, body gains. That force is called as restoring force. Body acquires restoring force. When the restoring force is equal to deforming force. Deforming force means applied force. The restoring force is equal to deforming force means definitely that body is perfectly elastic body. If the deforming force and restoring force are same, definitely that material, that property of a body is perfect elastic in nature, which regains immediately 100% of regaining capacity. If the restoring force is more, definitely its elastic nature is also more. Example for this elastic materials means, just to consider example, steel, rubber, and etc. Many materials are there, elastic nature materials. Now come to the opposite part of this elastic nature, that is plastic materials. Plastic or plasticity. What is elastic? Which regains after removal of deforming force. What is plastic means? Which does not regains after removal of that deforming force. Does not regains. Here regaining capacity, which regains after removal of deforming force. Here does not regains. Here also we are applying a deforming force. After applying this deforming force, the body deformed. Body is going to deform, change its shape or size. But this type of material does not acquire restoring force. That's why the body does not regains. Let us consider this is the one type of spring. We applied a certain force. After applying a force, its spring is going to increase its length. But removal of this force, the body will not come back to its original position. May it attains same equilibrium or less as compared to initial length. This is the original length, this is the change in length, this is also change in length, which does not regains as compared to initially. Example, we can consider paraffin wax. Or cast iron. Cast iron means rust hididirodu. Listen here. We can also consider these are the examples in plastic also. When we are going to consider this example as plastic, which loses the property of elasticity, it loses the restoring force. If the restoring force goes on decreasing, this elastic material is converting as plastic material. We can also consider the steel, copper, rubber. We can consider as plastic when its restoring force is going to decrease. Its elastic property is going to convert as plastic property. That's why we are saying that all elastic materials are converting as plastic materials. In the inverse, perfect elastic materials or perfect plastic materials, we are considering elasticity to plasticity or plasticity to elasticity. That's why conclusion point is no perfect elastic materials, no perfect plastic materials. It is going to convert from elasticity to plasticity. That's why we are going to discuss these are the part of mechanical properties of solids. We are discussing these things in the different parameters. Okay, I hope you understand these two definitions. The bookish definition of elasticity and plasticity are property of a body by virtue of which it regains its original shape or size after removal of deforming force. After removal of deforming force, which regains its original shape or size, is called as elasticity. Plasticity means which does not regain its original shape or size after removal of this deforming force, is called as plasticity. Okay. Next is very important, the continuation of this elastic nature we can explain in the form of stress and strain. But before going to that explanation of stress and strain, we should discuss this elasticity in the form of experimental model. That model we called as spring ball model. We are going to explain this nature graphically also. Elastic behavior of solids, and this elastic behavior we can explain with the help of spring ball model. Spring ball model, just to consider, this is the spring ball model. Here these molecules, these balls we are considering as a molecules. These balls we are considering as molecules, and between these molecules we are connecting a spring called as intermolecular force. We are considering between these two molecules, just we are connecting with the help of spring. Okay, this is the spring ball model, and these balls we are considering as a molecules, and between these molecule is called as intermolecular force. Intermolecular force. What is interatomic means? Force which binds two or more atoms together to make a molecules. Force which binds two or more atoms together to make a molecule is called as interatomic force. And what is this intermolecular force means? Force between the molecules is called as, force between these molecules is called as intermolecular force. Just to consider one interatomic space, these are the two molecules are attached with a certain intermolecular force. If suppose we stretched these two molecules, we stretched means we are stretching the spring. Stretching means which type of force is going to act? Attraction force. Developed a attractive force. Attractive force. If suppose we compressed these two molecules, this is the initial spring, we applied a force in this direction, we applied a force in this direction, compressed, which stretched means attractive force developed in that spring, we compressed means repulsive force is developed, repulsive force is developed, and this attractive repulsive force we are considering as restoring force restoring force developed in that particular molecules, that is nothing but molecular intermolecular force that we call as force of attraction, force of repulsion, intermolecular force and interatomic force. This will explain if you disturb a medium. We apply a certain force on this particular end, we are going to disturb the medium. Because of this force, the medium is going to disturb or its shape is going to change. The shape changes means definitely because of this deforming force. This deforming force is going to release means definitely the regaining force will helps to regain its original shape or size. Again the body attains equilibrium. That body again attains equilibrium means definitely that body a restoring force which is equal to deforming force. Deforming force. Then only it is possible to body attains equilibrium. Otherwise the body does not going to equilibrium. And this experimental methods we can explain by graphically also. Let us consider interatomic distance and this is the potential energy. We know that already potential energy is equal to mgh. The force is attractive means definitely potential energy is going to negative. Here is minimum potential. Just to consider this is the interatomic separation, that is R0. If the potential energy increases in such a way that it attains equilibrium. Listen here. If the separation, this is this much of interatomic distances of molecules, if this distance goes on decreasing, if the distance goes on decreasing means potential energy increases, separation decreases means potential energy increases. If the separation increases, also the potential energy increases. Why? Because at a particular instant the body attains minimum potential energy. Listen here. At a certain height we are going to throw a certain object. Initially it is potential energy is maximum. If body comes to the surface of earth, its potential energy is minimum. Always any particle, any matters, always it will come to the at minimum potential energy only. Minimum potential energy only. To come back to its minimum potential energy, again we separation increases means the potential energy goes on increases. This we can also explain with the help of force also. This is the distance and this is force. This is our interatomic distance, that is separation is, molecular separation is this much. Okay, listen here. If the interatomic distances are decreasing, decreasing means we are going to compress. We are going to compress. In this region there is a repulsive force. If the interatomic distances are increases, attractive force. That's why here is F is negative. If the interatomic distances are increases, attractive force. If the separation is increases, attractive force developed on that particular spring. If the interatomic goes on decreasing, interatomic distance goes on decreasing, there is repulsive force. Force is a repulsive force. According to this, we are going to understand how this attractive force is developed, how this repulsive force is developed. If the restoring force and deforming force are equal, the system is going to equilibrium. This is the basic explanation of elastic behavior of solids. Okay. Next part of this elasticity is stress strain curve. That is also very important, and that gives us how much force is going to act on a materials per unit area, that help us to distinguish materials of elastic nature. Okay, next is very important, that is stress. What is stress generally? Stress means restoring force acting per unit area. Restoring force acting per unit area. Generally we are saying that F by A. What is SI unit for this stress? SI unit, that is, what is the unit of force? Newton. What is the unit of area? Meter square, or we can also write Newton per meter square, or we can also write this formula F is equal to m into z by, that is, area. That mass is in terms of kg and z is acceleration due to gravity, that is meter per second square, and area is meter square. 1 meter get cancels. We can also say that kg per meter per second square is the SI unit of stress. We can say that in terms of Newton or in terms of kg per meter per second square. And it is very easy to write the dimensional formula for stress. Dimensional formula is always dimensional formula we are representing in terms of square bracket, that is M, L, T forms. M means mass in terms of kg, length per meter, time per second square, just to represent the powers. Nothing means 1, minus 1, minus 2. This is the dimensional formula for stress. What is stress? Restoring force acting per unit area is called as stress, and the SI unit we can say that Newton per meter square or kg per meter per second square, and dimensional formula is m1 L raised to minus 1 T raised to minus 2, and this is very important. This at present NEET means the last NEET 2020 NEET, they ask what is the dimensional formula for stress. Very important. Next, what are the different types of stress? Types of stress. The first type of stress is longitudinal stress. Longitudinal stress. What is mean by longitudinal stress? Stress means here also force is acting per unit area. How the force is going to act? Let us consider as cylinder of initial length is L. This is the cylinder, its initial length is L. Here we are applying a force. That force is normally over the surface of a body. Normal force acting on a surface of a body, force acting per unit area is called as longitudinal stress. A force is acting normally over the surface of a body, force acting per unit area is called as longitudinal stress. And its SI unit is also same, Newton per meter square. And here these longitudinal stress or this longitudinal stress are divided into two types. In that first one is tensile stress. Tensile stress. Tensile means, here longitudinal means we are considering about the length only. We are discussing about the length changes. By after applying a force, the length is going to change. Tensile means there is an increase in the length of the body. This is our initial length. After applying a force, its length goes on increasing. After applying a force, its length goes on increasing. Why its length is going to increase? We are applying a force. Because of this force, its length increases. Why? Because it is elastic in nature. Its length is going to increase. Here deforming force is acting on this particular cylinder. Because of this deforming force, the length is going to increase. This increase in length is L plus delta L. We are considering L plus delta L. Why its length is going to increase? Because of this deforming force. It's elastic in nature. That's why the length is going to increase. Tensile means after applying a force, length is going to increase. Increase of length of a body, force acting per unit area is called as tensile stress. Due to this force, length increases. That type of stress we call as tensile stress. Tensile means we are considering if the length increases due to deforming force is called as tensile stress. Second one, tensile, compressive stress. Compressive stress. Compressive stress means because of stress, its length is going to decrease. Its length is going to decrease. L minus delta L. Delta L is the change in length. Here we applied a force. Because of this force, length increases. Here we applied a force. Because of this force, length decreases. If the length decreases due to a force acting per unit area, that we call as compressive stress. Because of force, length increases. Force acting per unit area is called as tensile stress. And keep in your mind, here we are applying a force is perpendicular to the surface of a body. And in this case also we are applying forces perpendicularly. And these two types of stress, in these two types stress we are applying force that is perpendicular to the surface of a body. Here we applied force normally, we are seeing the variation of length in that particular cylinder. In these two types, if the length increases we call as tensile stress, length decreases means compressive stress. This is the first type of stress. Now come to the second type of stress, that is tangential stress. Tangential stress or shearing stress. Shearing stress. What is mean by tangential stress? Force which causes change in its shape or change in its shape due to force acting per unit area is called as tangential stress. Let us consider this is the A solid body is fixed on the surface. We applied a force. Here we applied a force. Because of this force, its shape is going to change. Its shape is going to change. This much of length changes. Here we applied forces normally. Here applied force is perpendicularly. Here applied force is parallel to the surface of a body. Applied force parallelly over the surface of a body, force acting per unit area is called as tangential stress. Here also SI unit is same, that is Newton per meter square only. Why? Because here we are applying a force, length and breadth is going to changes. Length into breadth is area. Force acting per unit area is called as tangential stress. Here we applied forces parallelly over the surface of a body. Force acting per unit area is called as tangential stress. And third one and very important stress is, that is volumetric stress. Volumetric stress or volume stress, or we can also call as hydraulic stress. Hydraulic stress, volumetric stress or volume stress or hydraulic stress. This is the very important stress. Why? Because when an object is going to immersed in a liquid, liquid exerts force in all the directions. Let us consider this object is going to immersed in a liquid. In that liquid, the liquid molecules exerting force in all the directions. Force is acting in all the directions. Let us consider this is the solid body initially. This body is going to immersed in a liquid. The liquid exerts force in all the directions. Liquids exerts force in all the directions. Because of this liquid force, this solid body decreases its volume. Why this volume is going to decrease? In all the direction liquid exerts a force. Because of that force, the volume is going to compress. Volume is going to compress here. In all the way we are applying a force means this is going to compress. Volume is going to decrease or increase? Decreases. In the same manner, here the volume is also decreases. This is the change in volume. This is the original volume. What is the definition of that volumetric stress? When an object is immersed in a liquid, liquid exerts force in all the direction. Because of that force, volume is going to decrease. This is called as volumetric stress. And these three are very important, and these three causes strain. Those are the types of strains. Let us discuss strain. Very important. The present year 2020, they asked 2 questions from this mechanical properties of solids. Keep in your mind 8 marks. Each question 4 marks. The very important bit. Next is second one is, that is strain. We know that already stress causes strain. Stress causes strain. When we applied a particular stress on a solid body, definitely the body gains a strain. We are going to discuss those properties here. What is strain? What is strain? Generally, strain means change its shape or size due to deforming force is called as strain, or stress causes the strain, or we can also measure the strain in terms of dimensions, that is change in dimension. Change in dimension to the original dimension change in dimension to the original dimension. We can measure strain in terms of dimensions. What is the basic definition of strain? Means the change in shape or size because of deforming force is called as strain, or stress causes strain. Listen here, what is the SI unit of strain? We know that already. Dimension means just we are writing in the form of square bracket, that is MLT form. Just take any one of the dimensions here. Just I am considering, let us consider length. Let us consider length. This is our initial length, that is, just to consider this is 1 meter length. After applying a force, its length is going to increase, that is 1.2 meter. After applying a certain force, its length is going to increase. Here I am considering the dimension is length. What is the measurement of dimension? That is change in dimension. Dimension instead of dimension, what we are considering here? L. Okay. Change in length. Change in length with respect to original length. Original length. What is change in length here? 1.2 meter. And what is the original length we are considering? 1 meter. Meter get cancels. It is nothing but 1.2. What is unit here? No unit. Strain does not have any units. No unit. Keep in your mind. Strain does not have any units. We are measuring in terms of numbers. We are measuring in terms of numbers. In the strain also there are 3 types. In the stress is also we discussed the 3 types. Similarly here also 3 types of strain, that is, first one is same, longitudinal strain. Means that longitudinal stress causes the longitudinal strain. Or we can define longitudinal strain in the form of measurement also. Here dimension. In the longitudinal means we are discussing about the length. We are discussing here length only. What is longitudinal means? Change in length because of deforming force or because of stress. When I applied stress on a particular solid body, its length is going to change. That we call as longitudinal strain. Or we can also measure longitudinal strain, that is change in length. Change in length with respect to original length. Just to consider change in length as delta L and original length as L. Here also no unit. No SI unit. No SI. Just to consider those diagrams here also. Second one, that is longitudinal strain, is the first one, and second one is same, tangential strain. Tangential strain or shearing strain. This is very important. Why? Because already we consider this is the solid body. Initially it is fixed. When we applied a parallel force on it, its shape is going to changes. Already we discussed these things in the stress. Here the very important is the tangential strain measured in terms of angle theta. Angle theta. Angle theta means, just to consider it as a tan theta. Tan theta means opposite by adjacent. Opposite by adjacent. Opposite is, this is the change in length, that is delta L. This is our original length L. This is our original length. This much of length is going to change, that is delta L by L. Or we can also say that here we are considering about the length, here we are considering about the shape or size. Change in shape with respect to original shape, or change in size with respect to original size. We can also measure like this. Change in shape or size with respect to its original shape or size. Here also we are considering delta L by L. Same here also, no unit. Next one is very important. Third one is volumetric strain. Volumetric strain or hydraulic strain. Already we discussed this. When an object is immersed in a liquid, this object exerts force in all the direction. Because of this force, the volume is going to decreases. This is delta V and this is V. How we are going to define volumetric strain? Change in volume with respect to its original volume, that is delta V by V. Change in volume is delta V, original volume is V. And these three types will help us to discuss the further thing, that is modulus of elasticity. Always keep in your mind that may be stress, that may be strain. Longitudinal means we are considering about the length. Tangential means shape or size. Volumetric means we are discussing about the volume changes. By applying a stress causes the strain, stress causes the strain. Always keep in your mind these are the very important types of stress and strain. In the next class I am going to discuss the continuation of this stress and strain, that is modulus of elasticity. Thank you.